So thanks for coming on talk today. I got the title Software and Modern. Actually, I've got deployment in the handout, and I've got development down here. I can't really make my mind up which one applies better, so I just kind of change it depending on what I'm feeling like. So it went to development on the slides. If anyone's got any questions, feel free to ask as I go along, or wait till the end, either way. The other thing is, if I speak too quickly, wave at me, or if you've got a rocket, fire it at me. It's a bad habit I have got when I speak, and I'm trying to get out of it, so you can help me out. Just kind of wave at me and go, you're talking too quickly. So what is this talk about? This talk is about, actually it follows on, if everyone went to Josh's keynote last night, it follows on really well from that. This talk is about trust and your software deployment, and things you might be trusting now and maybe not realizing it, or things you might want to change about how you trust software and how you trust software when you're installing it. And when I'm talking about modern software development, I'll try how to describe it. If you think of it like Node and the way Node applications are installed, it probably typifies it. You're using Node, you're using NPM, you're using repositories of software components. And I think if you look at what, again, came out of Josh's keynote, he was saying that only people only develop 10% of the code they deploy. 90% of the code they deploy is dependencies. It's that kind of model I'm thinking about. So very briefly, the about me. I've been in IT security and information security for X years now. I used to have a number up there, but it got too big. It got depressing, so it's now X. X minus 5 in security testing. So I'm a security tester. On a good day, I break into applications. On a bad day, I write word reports about the applications I broke into. And I'm a managing consultant at NCC Group, who are a large international provider of security testing and other services. One of the cool things about being a tester, though, is I get to work remotely. So I live here, which is the Scottish Highlands, a place called Loch Goilhead, which is very pretty. Other thing I'll mention is, has anyone heard of Security Stack Exchange? One. Okay, Security Stack Exchange is really useful. It's a place you can go to do questions and answers about security. So if you've got stuff you want to answer or questions you want to ask, there's actually a really helpful community on there. And the reason I mention it explicitly is this talk actually came about from some conversations I had on Stack Exchange. There's a chat room that goes with it called the DMZ. And I was talking to some guys about articles that I saw on a site called Hacker News. So if anyone's heard of Hacker News, it's like kind of if you haven't heard of it, it's a more startup/tech focused version of Reddit. And a lot of kind of chats about software development and deployment go on there. So that's how I came out, talking to a guy called Terry and a guy called Avi Duglin. And the way it came about is there were some articles talking about this software deployment method, which if you've deployed a lot of development tools recently, you've probably seen applications doing this, right? It's actually got a name now. It's called curl bashing. I didn't know this till, I think, 2 days ago. I read it's called curl bashing now. And there's even a Tumblr dedicated to places that do curl bashing. And so when I see this, I'm a security guy, right? So my initial reaction when I saw it is, I don't like this. This scares me. But long since gone are the days where an IT security person can just say, no, you must not do this, it's bad. No one listens to that anymore, and I don't think, not sure they ever did, but if they used to, they definitely don't now. You've got to be able to say, what's wrong with this? So I look at this in my head, I'm going, wow, this is terrible. But I can't just say that to people. So I have to say, what's wrong with it? So I tried to come up with a way of thinking of, what's wrong with curl bashing? Why don't I like this? Why does it scare me? And this is what I came up with. A tower of trust. And that font's not worked very brilliantly. Oh well. If you think about trust, when you trust someone, think about it as, this is someone who has the power to betray me. That's a great way to think about trust. So if you're thinking, I trust this thing, you're giving the thing you trust the power to betray you. So when I install software in this way, who am I trusting? Who am I giving the power to betray me? I'm giving the application developer the power to betray me, right? So when I do this, I'm getting a shell script they've written, I'm piping it into a root shell on my server. If they wanted to put malware there, I'm going to install their malware. I'm going to install it as root. I'm also trusting that they're competent. So if the application developer doesn't have good operational security, then I probably am in trouble because they might have been compromised and they might have bad things happen to their script. And the other thing is I'm trusting the software they're installing is going to be written securely. That could be a problem. I haven't looked at it because I'm just going, get this shell script, do whatever it wants on my system. So I'm trusting that they're going to have done things securely. The thing is, I'm not just trusting them. I'm trusting the dependency developers. So we've said before, right, a lot of software these days, when you install it, it will go and install sets of dependencies. So I'm not just trusting this application developer. I'm trusting every dependency developer. And there's a nice little kind of arrow there which indicates it's not one level of dependencies, right? Dependencies have dependencies which have dependencies. And I'm trusting the same thing about them. I'm trusting that it's not malware. I'm trusting that they're competent. And I'm trusting that they're secure. And so we'll carry on down the stack. Repository provider, right? So this was hosted on a server. I'll call it a repository. I'm trusting that person too. So if that repository provider wanted to be malicious, right, there was no digital signing on that script. There was nothing that said the application developers put it there. The repository, the person who owns that server can change it. It's just a shell script. So I'm trusting them too. I'm trusting the cloud provider. So these days when you see an operating system image, it's almost never an actual real server, right? It's a cloud system. So underneath that, there's a cloud provider, and they've got access to it as well. So I'm trusting the cloud provider. And this, I mean, that was kind of in passing, but that link was not SSL. You don't always see that, but I have seen it. I've seen non-SSL links. And if you do this over a non-SSL connection, you're also trusting these guys too. So you're trusting the DNS provider to be right, because if they want to, they can just say, you thought you were going here. Actually, I'm going to say the DNS of that server is over here. So you're going to get a different file. And you're trusting the infrastructure providers. So every single hop from the server to the client could compromise that script if they wanted to in passing. So you're basically trusting. These are all the people. You do that, you're saying, I am comfortable with the idea that everyone in this stack has got the power to betray me if I want them to, or whether I want them to or not, in fact. So I looked at this, and that was kind of my articulation for why I don't like this, why I would be worried about this, depending on what I was doing. If it was maybe just like a complete throwaway system, I might not care. But if it was a production system, I really would care, because that's an awful lot of people to depend on. Then when I was reading these articles about this problem, I came across this sentiment on several occasions. And they said, how is this any worse? And I've seen this several times. How is this any worse than any other method I would use to install software? At that point, I really did go, what? Seriously? That's the best we've got? So it's curl bashing, or things like curl bashing are the best we can do for installing production software. And this really concerned me, because I was thinking, hang on, that's not what I thought was the case. So I thought, okay, let's look into this. And so I thought, right, what other options are there? And this is some of the options I thought I'm going to look at, right? So we've got NPM. So if you do JavaScript stuff, you'll use NPM. Ruby gems, PyPy, NuGet, PHP's got one as well, Composer. Basically, every single modern programming language that's used heavily today has got some form of repository that you install components from, right? And so I've investigated some of them to say, surely these are better than curl bashing, right? Surely there's more to this than actually, there's better protections. So what thought I'd do, in terms of actually exploring that, look at two attacks. So let's take an attacker's viewpoint and say, I'm a bad guy. I want to do bad things to a system, to a package. How would I do that? What controls might there be that would stop me doing that? And what controls aren't there? So what would go on here? Before I do that, though, the nattily titled Rory's 2014 or greater rule of security. Someone said I should call this Rule 34 of security, but I wasn't sure I'd get away with that, so I'll just leave it as it is. Basically, the thing about this is, I've been in security for a long time now, and the number of times I've heard, yeah, that's a weakness, but no one would really ever do it. If you're in security, you will have heard that phrase. So people just say, yeah, it's a problem, it's not right, but no one would exploit that, would they? I think if nothing else has come out of all the revelations from Snowden, of all the revelations of state-sponsored cybercrime, of all the revelations of really cool attacks, we should have got over that concept by now, right? People have done the wackiest stuff that security people had thought, yeah, maybe you could do this. People have intercepted routers from the supplier to the customer and reflashed the firmware. They've compromised the entire telecoms network of a country to get access to one of their customers. They've compromised whole VPS providers to get one server on one of their customers, right? Basically, and also the other thing is, I don't think I'm that bright, okay? I'm not so intelligent that I think I can come up with threat scenarios no one else could have thought of. So I figure now, if I can think of this, someone else has already done it. And I'm fairly confident in that statement because I'm not that intelligent. So let's talk about the attacks. I've got two attacks. The first one I'm calling the short con. So the short con is, I'm a bad guy, right? I would like to compromise some libraries, and I would like to do that as a means of compromising some servers. I'm not too fussy about what servers I get. I just like to get some, maybe I want to use it to host malware or mine bitcoins. Maybe I'm going to get lucky and I'm going to get some customer data out of them. I'm not too bothered. But I've come up with this idea that I'm going to do it by modifying a package, and I'm going to put some malicious versions in there. How would I do that? So the first thing, I've got to modify some library, right? So I've got to modify someone's software library, and I've got to actually then get it out there. But the first thing to do is modify it. Get the code. Okay, this is super easy these days. This is all open source software. Go to GitHub. You will get the code. It's open source. You can download a copy probably that way, but you can also just go to GitHub. Everyone's on GitHub. The cool thing about GitHub is it'll also tell you things like who the developers are. So you get some good intel if you're trying to be an attacker and you want to think, who am I going to have to compromise here? You get to know who the developers are because it's all on GitHub. Then I need to modify the library to execute my code, right? So I want to have it do something bad when it's run, when it's installed. Do I have to wait for the library to be used? So when I started looking at this, I was thinking, I'm going to have to wait for the library to be used, and maybe it never will be. You know, my library gets installed, it's a dependency. Maybe no one ever calls the function that I've backdoored. I was thinking, this is going to be really, you know, I was thinking about kind of wacky ideas, how I would get that to happen. And then I looked into it, and no, post-install hooks for the win. So it turns out that pretty much all packaging functions have a concept of a post-install hook. And what that is that's a piece of code that's run when you install the package, not when you use it. So as soon as you install it, your code's run. And it can be really super simple. This is NPM, and you see right here we've got post install, touch that. Basically, any command you put in as a post install in an npm package.json file will be run when the package is installed with the rights of the installing user. So if you want to get access to a system, put something in the post install, and it'll work. And they've all got this. So NuGet has got PowerShell scripts. So basically there's a thing called init.ps1 that will run when you install the NuGet package. And RubyGems has got it in Rakefile, and they've all got it. But they basically, the idea of it is to do like extensions, like C extensions and stuff. In a lot of cases, you can get root that way. So some packages, you'll install them system-wide, and you'll actually get a root shell, which is kind of nice. But it's that simple, really straightforward. And it runs, so it runs at install time as the installing user. So no need to worry about waiting for someone to call your library. It's just going to work. Choosing a target. So obviously, as an aside, choosing a target is kind of important. Dependencies are installed too, right? So it doesn't have to be the package someone actually installs. It could be a dependency that gets installed. And luckily, NPM actually gives you a really cool thing. If I was an attacker, I would go and look at this, because it tells you what the dependent libraries are. So this is one package, quite a well-used one. But the cool thing is down the bottom, and 9,114 more, right? So there's like 9,100 and whatever that is, 30-something packages which depend on this particular package. So if you can compromise this package, you can get everyone who installs 9,100, a lot of packages. Cool. So excellent way to pick targets. Right, now I need to push a new version, right? So I've got this copy of my malicious library, but that's no use to me. It's on my machine and my machine alone. This is totally pointless. I need to get it up onto the repository. Now that's obviously going to be tricky. Well, so how is access controlled to these things? So when I went to sign up for NPM, for RubyGems, for PyPy, for NuGet, I thought maybe there's like a whole validation process before I can push libraries. Like there's a whole like process of things I have to go through. Username and password, register with whatever you want, and that's it. You can push any code you want. Obviously your own code. You can't push someone else's library. The cool thing is they all used to use static username and password. Right? There's no two-factor available at all. The other cool thing is, in a lot of cases, they store them in dot files in the clear. So, because it's nice and easy that way. So if you're pushing a new version, you don't have to put your creds in. So if you can get someone's, so PyPy, they just recommend you do it. RubyGems stores an API key. NPM stores it in base64 encoded, so it's totally encrypted. So you can't get anywhere like that. But it does. It stores static username and password. So if I can get a developer's laptop, I can get access to that somehow, like malware. I can read-only access. I can get their NPM creds. I can get their RubyGems creds. And at that point, I can push code as them. Right? Other cool things to note about that, if you're an attacker, is there's no password quality on a lot of them. So some of them have like a basic password quality requirement. Other ones will let you set single character passwords. So there's no guarantee people will have good passwords. And I did some basic checking for account lockout, nothing too heavy. On most of them, NPM has a lockout for a little while. Other ones have no lockout whatsoever. So if you want to try and brute force creds, absolutely no problem. And the usernames are usually email addresses, which you can get off GitHub. So if you want to attack people, just get the email address then. either go through all the dumps of various passwords and hope you get one that way, or brute force, or a variety of other ways. But you get the picture. This isn't heavy, hard to get into. Lack of curation. So this is probably the most important point people should take away from this presentation. A lot of people think that package repositories for software libraries are curated in some way. There's some quality check, there's some review. No, there isn't. There's none at all. I've put malware onto at least 4 repositories. iCar, nothing fancy. It doesn't get caught. It's been there for weeks. Right? So there's an iCar package up there now, which I put up there. It's been there for weeks. So they're not doing antivirus scanning. They're not doing checking. I've put stuff that does Metasploit bind shells. It's set there for weeks, actually months for that one. No one is checking for this stuff. No one is looking for malware. And it's kind of obvious when you look at the numbers. So NPM clocked across 150,000 packages yesterday. So they have 150,000 packages with a rate of about 300 new packages a day. There's no one doing manual checks on that volume of code. Physically impossible. So there is no curation. If you think you're getting a curated, and actually if you dig into the documentation of each package repository, they will say that to you. If you've ever been in Visual Studio and you go to the NuGet package section and you look at it, it does say at the bottom, you need to check to make sure you trust this. It gives you no idea how to do that, but it does say you need to work out whether you trust this stuff. Lack of digital signing, right? So digital signing would help us here, because if I compromised someone's username and password, and I didn't have their private key for their signing key, I wouldn't be able to push a new version. I would need more access to do that. There is no digital signing on some of them. On other ones, it exists, and nobody uses it. RubyGems has it. I tried installing some common packages and requiring signed versions, and none of them installed. No one uses it. So there's no signing. And if you compare that with things like Debian, with the Linux repositories, which are perhaps kind of a predecessor of this kind of installation method, they'll have digital signing, right? So they have digital signing by the maintainer, not by the developer, but at least they've got some level of digital signing. You're going to see some protection from that. It's not perfect, but it's something. And people download your code at this point, right? So I've pushed my new version. I've managed to hack someone's password, either a brute forced it, or I've got a copy of it. I pushed a new version, and people then download your code. As an aside, this was kind of funny. One thing to watch out for, it's kind of in a similar area, is Docker. This didn't come out brilliantly. You can kind of see it up here. Docker files, which is how Docker containers are put together, are just big bash scripts, kind of. Think of them like that. And the cool thing is they have hierarchies as well. So Dockerfile 1 will rely on Dockerfile 2, which will rely on Dockerfile 3. And they do cool stuff like wget HTTP Node.js, and then just go and get a version of Node from an unencrypted web server, and then they can install it. So if you're using Docker, you have to really watch your Docker files as well. So they have the same kind of problem. Profit, shells. So I've got this up. As you can see, there's not really anything that's going to stop this happening. There's not really a lot of controls in place that are going to prevent it. And it's fairly straightforward at this point. Let's see if I can get this done. Is that going to? Well, yeah, OK. So if you wanted to actually exploit this, you can use Metasploit to create bind shells in programming languages. So you can say, that one's a Ruby shell. So that basically just gives you a whole lot of stuff that you eval. And when you eval it, you shove it into a rake file. Wow, those ones are bad. Used to do eval down here, but that's just all the Ruby shell stuff from Metasploit. And oh, wow, that's totally unreadable. It would show a shell. Basically, at that point, you got a bind shell. Someone connects to it, they get root, no authentication. But yeah, black on black, bad idea. So fixing this, great. So I'm a typical security person. I've come up here and I said, there's lots of bad stuff. It's really bad. You need to worry. How do you fix this? Audit all the code, and these won't look great either. I've seriously seen this suggested. All right, on a number of times I've seen this discussion. People say to me, yeah, just audit the code, right? Just audit all the code you install. And I say, well, that's interesting you say that. That is a list of packages installed when you install Metasploit, right? So Metasploit is a common tool. I thought I'll pick that as an example. You can't see exactly what they are, but you can see there's lots of them, right? We've got, like, what, 30, 40, 50, and there's some great ones in there. That one's called R. Kelly Remix. Right, that's the name of the package. So I'm trusting R. Kelly, the developer of R. Kelly Remix, not to be malicious. I don't even know. It's version 0.06, so he's well along with the development. And I'm trusting him, right? Because he's just installed something. His Metasploit, needs to run his root. So I've just installed it. I've just trusted this guy. I have no idea who he is. And how much is that? How much code are we talking about here? 450,000 lines of Ruby, 119,000 lines of ANSI-C, and carries on. So we've got like 600,000 lines of code, roughly. Anyone here want to audit 600,000 lines of code manually for backdoors that could be well hidden every time they install a piece of software? I don't. I'm not going to. It's just not possible. It's not practical. Audit all the code, because you can't even use static analysis to find this stuff. Because static analysis doesn't do very well when people are deliberately trying to hide the thing. It's more looking for patterns it would recognize. Any decent attacker is going to put something that's not an obvious pattern. Trusted repositories. Okay, is trusted repositories an idea? Well, what's trusted? We said before, trust is someone you give the power to betray you. So who do you want to give the power to betray you to? One option is, and a serious option would be to use the Linux distribution packages. Sometimes they will have these things packaged up for you. The problem is they tend to be older versions, and that's the reason people don't use them, right? So they fall behind quite quickly. Docker, for example, fallen behind the version because it's a slower process, because it's got more steps, because it's more controlled. So the very nature of that slows it down and makes it potentially less useful, but it makes it more complex for an attacker to compromise. So they'd have to get multiple different sets of people and compromise them and bypass QA checks and do more stuff. Not saying it's impossible, but I am saying it's more difficult. If you run your business on this stuff, how about having your own internal repository, right? That would be a valid idea. Don't install directly from RubyGems or NPM. Have your own internal repository. Do some basic checks. Run an antivirus scanner over all the packages. Put it in a malware sandbox, maybe. You put things in a malware sandbox, check for things like, oh, this is making a funny connection to some server I've never heard of. That's a bit of a red flag. So look for things like that. That's actually I think that's perfectly valid as an idea. So, better repository security, right? So better repo security would help here. Digital signatures would definitely help. 2FA would help. Operational security improvements, so things like if an email was sent to a package owner every time a new version got pushed, that would flag up this kind of problem. The thing about that is, are the repository package managers going to do it? So I don't think any of them aren't interested in security, and I don't think any of them are trying to do a bad job at this, but I do think it's maybe not the top priority for them. They've got other things to worry about. For example, digital signatures, that's a lot of work, right? If you're going to start saying everyone who deploys to our repository is going to sign their code before they push it, the real worry is that someone else will just start a new repository that doesn't do that and is nice and easy to use, and everyone will move across from one to the other. If you look at how much people in the development world hate the Apple signing process, if you think about how Apple mobile apps for iOS get put out, they hate that, right? It's slow, it's clunky, it requires them to do stuff, they have to pay money to get access to it, but how much, there's a lot more control in there. It's not perfect, but there's a lot more control than just do whatever you want. So yeah, I think that that's definitely possible, but I think people would have to start asking for it. And the other problem with it is, obviously if you're not getting this stuff, everyone should go back and ask for a full refund of all the money they pay to the package repository owners, which is nothing, because they're free. This is the big problem. They're free services, so really people don't have a lot of rights to ask. You can kind of say, hey, I'll help you, but you don't have any right to ask because, yay, it's free. I also mentioned there is some good work being done by these guys, the update framework. So they're focused on the scenario of what happens if the package repository gets compromised. How could we defend against that? And it's a lot around digital signing. And what I've seen is they've done versions for different languages, and a lot of time people have looked into this, and they're definitely looking at it, and it's on the roadmap, but it's on the roadmap and it's kind of staying there. I've seen posts from 2 and 3 years ago saying we're going to implement this. Unfortunately, in most cases, it's not there yet. So again, I think it's a priorities question. They've got other things to be doing, like keeping the thing going, putting out new features, doing their day jobs probably, if they're not getting paid for it. So it's there, the information is there, but not deployed. So the long con. So that was the short con, right? So that was just an opportunistic attacker. I'm trying to get in and do this stuff quickly. And I'm just going to try and get something quickly. But what about the long con, right? So we've said there's a lot of nation-state attackers out there. There's a lot of high-end cybercrime. There's guys who can put money into this, right? There's guys who can put a lot of money into this. If you look at the kind of money that is spent by the big defense agencies, the kind of money you need to do this sort of stuff is trivial. So if I was a big attacker, how would I do that? Start an open source library, right? Start your own open source library. Why not? Make it good, make it popular, and people will use it. What do you really know about the people who write the open source software you use? Do you know who they work for? Do you know what their financial circumstances are? Do you know whether they've just taken a new job with a new company? Do you know whether someone in their family is sick and they need money. All these things you don't know. I don't know, no one else knows. If I was a well-funded attacker, I would just either start an open source library or take over one that gets dropped. So a lot of open source libraries will get dropped after a time. Someone else picks them up. And I kind of go back to GitHub like a couple of years down the line, and I go, oh, this isn't where it used to be. But I didn't know. I've been installing that library for years, and I didn't know that it's moved owner. So, and maybe everyone validates the owner before they hand it over, but I kind of doubt it. Or really cool, start your own package repository, right? Because it's a thankless task, and no one pays you for it. So if you wanted to, start your own one. Because without developer signing, the package repository owner is in the position to backdoor every single package in the repository anytime they want to do so. That would be a great way of doing it. Or indeed, even better, just offer cheap server space to someone who's running a package repository, because they want that, right? Server bandwidth, this stuff's expensive. If I give you guys free package, free server space, free bandwidth, you probably take it. And at that point, I'm in a position where I can backdoor any package on that library unless there's digital signing, which we just said there isn't. Yeah, at that point, if I was a bad guy, I wouldn't be so dumb as to compromise a package that everyone downloaded, because that's kind of obvious. Someone's going to spot that. What I would do is I would modify specific versions that were going to get downloaded to specific targets, probably based on IP address, based on netblock, based on something like that. And one of the problems we've got at the moment with this stuff is there's no way for, if I download a package and one of you guys downloads the same package, can we tell we got the same thing? Nope, not easily, not trivially. You could do it all manually, but no one's going to do that. There's no way to actually prove that we got the same thing. Fixing this, wow. I put loads of question marks because I have no idea. If you think about how you would fix this, you have a situation where we're downloading hundreds of thousands of lines of open source code from people we don't know. How do we prove that they are who they say they are, that they are not going to do bad things to us, that every part of their chain that has been used to develop this is secure to a level we're happy with? I don't really think that's trivially possible. The only answer I could come up with was stop using it all and use software, either write it all yourself, so reverse that 90-10 split that Josh talked about yesterday and say, actually, we're going to do 100% in-house. Or, depending on who you are, you could go to a corporate and say, we're going to have a contract with you that says if there's any bad stuff, we've got the right to sue you for enough money to make this worth it for us. But again, I can't imagine going to an IT management senior manager and saying, hey, we need to start spending a huge amount more money than all our competitors are spending for our software. I just can't imagine that conversation ending well for the person who says that. So I don't actually think there's a really good, easy fix to that one. But it's something people should be aware of, because remember, it's not just, people will say, oh, well, nation states are never going to attack me. Why would they? But we see all sorts of fun stuff where nation states have a kind of, it's like, you're not have to be like a defense agency. You could be something where a government could get commercial gain in a negotiation for a company in their own country. There's all sorts, or you could be a charity. Some charities will get attacked by nation state level attackers because there's something to do with human rights. That sort of thing can be a problem. It's not just big defense companies that have to worry about nation state attackers. So how much a problem is this, right? Here I've come up, I've said, look, lots of bad stuff. It's trivially possible to compromise these libraries, but is it really a problem, right? Is it really an issue? So there's a cool site called Module Counts, and they have a list of modules, right? And this is from last week, I got these stats. So here we have some of the stats for some of the libraries I've been talking about. You can see the kind of numbers of 147,000 packages, 36,050, lots and lots and lots. So there are lots of packages out there, and they're growing at a reasonable rate. So you're seeing a lot of new packages. So there's tons and tons of libraries out there. So yeah, that's a problem. But if no one's using it, who cares? Oh, wait. So NPM, a couple months ago, this one, 3,900 packages a second being downloaded from NPM. So it's not to say these things are not in use, because they absolutely are. I remember my thing before about I'm not the brightest guy in the room. This is a cool thing. Can anyone spot what's wrong with that? If you use Python, you might be able to spot what's wrong with that. No? Okay. So what's wrong with that is Python has got a really cool, very kind of base integral package called setup tools. The key is the S. That one's not got an S. It's setup tool. Someone else uploaded this, and it doesn't do what setup tools does. What it does is it gets a whole lot of information from your machine and sends it to a server on the internet if you install it. So this guy, and he got caught because it was kind of obvious. It didn't actually do what it was meant to do. And so he got kind of like rumbled fairly quickly. But he had it up there, and he got some downloads. He got, what, 245 downloads. That's not unrespectable for a very, very, very basic hack. And he actually said that, I think it went up on his blog saying afterwards, oh, I was doing this for a research project. Maybe that's true, right? I don't know if that's true or not. All I'll say is, when I was doing mine, I put some packages up just to test what you can put up and what you can't. I just made it really clear. I said, do not install this package. This is bad. So hopefully no one will install it. But yeah, so people are doing this. This is not some like revolutionary thing. And it was interesting, when I was digging into all this, and I read through like various different languages and their kind of security communities and what people are, this is a known issue. It's just not well known, right? So the Ruby guys, there was a guy who did presentations in 2009. There are people talking about it on NuGet a couple of years ago. There are people talking about it on NPM. This is a known issue, but it's not a very prominent issue. And that's what concerns me, is the fact I don't think most people realize. So yeah, so that one was an interesting hack. That was a couple months ago. So in conclusion, so what would I say about this? It's all bad. No. Understand your trust model, right? So depending on who you are, you might be totally happy with this. If you're a developer, you might say, actually, this is fine. I don't mind this. I'm happy with the trade-off. I'm happy with the fact that my development is easier, it's faster, I can do more stuff. But if you are, for example, a large bank, as a good example, and you're thinking about using a NPM-heavy project for your next major banking app, you might want to seriously consider how you do that and consider whether you're really comfortable with doing that. Are you comfortable with trusting these libraries, trusting the fact that everyone who develops these libraries is going to have perfect operational security, because everyone's great at password management. Consider restricting your use of repositories. If you are concerned about this, if you are running your business on it, think about, I personally, if it was me and I was running a company based on this stuff, I would have my own internal repositories. I would not be pulling directly from internet repositories because it's just too dangerous. And you're just not going to know until it's too late that something bad has happened to you, and it could do all sorts of horrible stuff. If this is really important to you and your company really runs on this stuff, and a lot of companies do, contribute, right? So a lot of these things are open source projects. RubyGems is an open source project. They will be more than happy, I'm sure, to take funds from people who are interested in security. Tell them it's a priority. Say, hey, I would really like you to improve this stuff. I think that makes sense. If you look at all the $100 million, billion-dollar companies that run based on open source software, you would think there would be ample funds to handle this kind of stuff. But, Questions? Yeah. 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 So yeah, the questions around sandboxes and how you would run all the code. You're right. I don't think you would find everything with that. I think you would be more looking. You could look for install time stuff. So if you install it, what I was talking about there is kind of basic install hooks, where someone hooks the post install and says, I'm going to do something at this point. And you could find that kind of malware that way. So you could find something that happened on install. If someone hides it in a library that only gets called, every 4th week, you're right. And that's one of the problems of things like any dynamic code analysis. How do you actually make sure you hit every code path? So yeah, I don't think that's flawless. I think as a kind of a band-aid mechanism to say, against the short con, against someone who's just done something fairly basic, I think that would help. Against the longer one, probably not. Any other questions? Oh, sorry, yeah. Sure. Oh, yeah. So the questions are, you could get very paranoid and think, everything could be compromised. And you're correct. I think that this is all about, trust is all about a spectrum, right? It's not a binary decision. And that's the kind of important point, is making a conscious decision where you want to be. So with Ubuntu, yeah, you could say, right, I'm not going to trust them. And one option a corporate could take is say, I'm only going to trust people who I've got a contract with. And I'm going to write the contract in such a way as there's a good financial penalty, because I'm a company, so what I care about is money. There's a financial penalty in play that if you do that, if you let malware get into my systems, I can sue you. Now, that's one of the major problems with software security these days, is that doesn't generally exist, right? Someone can ship something hideously insecure, and there's no liability. If I was a company, that's how I would try to defend myself. I would say, right, I'm going to move more towards things that I control. Or if I don't control them, I'm going to recognize that and say I have to put other things in place. But yeah, one of the things that you see some of the more secure people looking at package management is looking at reproducible builds and saying, right, I want to have a situation where I sign the source, sign the binary, and then you can get the copy of the source, compile it, and produce the same signed binary. That's actually quite tricky to do, it sounds. Maybe it doesn't sound too hard, but that would give you some protection against that. So you could say, right, I'm going to have signed, signing of source, signing of binary, and produce a reproducible build, and allow you to actually check that the thing that's come out the other end is the same as the source that went into, or the same as the compiled version. But yeah, ultimately, everyone has to make a decision. I think for me, it's just a more question of saying, I'm going to have my eyes open while I'm making this trust decision about where I want to sit. Yeah. So what am I doing about it? Well, I personally, I'm getting more paranoid. I mean, I have been for a while about, I used to, many years ago on the internet, download things more or less freely. What I'm doing myself is I'm getting far more paranoid about things without digital signatures. Far more paranoid about things that are fresh, brand new. So the thing about the short con is it won't last very long, right? Enough people will install something, someone will notice it's not right, and it won't last. Defending myself against the kind of long con, is some software package I use have someone who works for a nation state? I can't personally think of a good way to defend myself for that. But the short con stuff, I will check digital signatures. I actually I downloaded, when I was doing this stuff, I downloaded Node.js. And Node.js has a hash file for it, and it has a signed version of the hash file. And then I thought, okay, I'm going to check this signature. I'm not just going to trust this. I'm going to, make sure it's the right. It took me about half an hour to find the key. So the key wasn't anywhere on their website. It was actually one of the individual developers' keys. And the only reason I could confirm it was his was I found a thing on GitHub where someone had done the same thing. I found one guy. So that kind of tells me how many people are checking Node.js's signature when they download it, because it took me ages to find it. And I found it on Keybase eventually. I actually think Keybase could work really well for this. I mean, people use Keybase. It's a kind of put your PGP and then attest that you've got a key on Twitter or on GitHub, so you can kind of tie your identities together. I actually think that could be used quite well for digital signing, because it would allow you to say, okay, at least I can confirm that the guy who has the key, that has this GitHub account and this Twitter account, is the guy who signed my code. It still requires people to take good care of their keys, which is another question altogether, because that's not trivial. But yeah, so in general, I've just kind of tried to be more paranoid about where I get software from. I definitely don't download binary executable software from random sites anymore. I maybe used to do that, but no way. It's just too risky now. I just have this horrible feeling that I would be really embarrassed. I'm a security guy. I don't want to get compromised. Not to say it won't happen, but you do what you can. Any other questions? Cool. Well, thanks very much for that.